Hey everyone, welcome back to some chemistry videos. In this video I want to take you through some of the basics of stoichiometry. We're going to do some basic problems. The worksheet that we're going to go through is part of the assignment, so what I want to do is just probably work the first problem from each section, and from that it'll probably be good to go. Let's start with a quick glance. In the previous video I told you what stoichiometry is and then how we can use it. So in this first example from the worksheet, it's just using mole ratios. Let me remind you that we're using the coefficients here. And what I would do is if I want to take a ratio of the moles of aluminum to the moles of oxygen, all I'm doing is adding the coefficient. So it's a 4:3 ratio in terms of moles of aluminum to oxygen. That's it. This, folks, is stoichiometry. Using that very simple ratio, that's it. It never gets more complicated than just taking the ratios, and it's the ratio when we apply the ratio, it's going to be the ratio of whatever we're looking for over what we're coming from. So using units and dimensional analysis is going to help us set it up correctly. But folks, this is it. In the middle of every problem we do the stoichiometry, it's just a ratio. And it's really easy, as I hope you saw from the introductory video. So I want you to remember that. You're always going to have the ratio step. Now what students get kind of hung up on is what happens before and after the ratio. So on either side of using the ratio, we have some optional work. Sometimes we have to do it, sometimes we don't. What I call it is prep and polish. And what I mean by prepping is that we have to use one of our previously learned methods to get to moles. So our job is to get to moles by hook or crook. And we've learned several methods, or you've learned several methods. Right now we're learning grams to moles, and that's all we're going to be using right now. But we're going to be able to use PivNert to get moles. That's a tool that we can now use to get the moles. Or we can use molarity. We took a brief look at molarity earlier in the semester. So whatever tool it takes, and there's more than this, but get to moles. And once you're in moles, now you can apply the ratio that we call stoichiometry. And then after that, what I mean by polishing it is to take the stoichiometry result, which will always be in moles, and then convert it back into something that the problem wants you to have, like grams. Or you can reapply PivNert to get maybe liters or pressure or whatever you want. And then we could also plug it back into molarity. So those same tools that we use to prep, we can also use to polish it off if we need to. And so that's going to be part of your job, is to figure out how far to go each time. The most we have here is 3 steps. The minimum is 1. So you're going to have between 1 and 3 steps on each of these problems. So let's do, like I said, 1 for each type. Let me grab my calculator here. And we're going to use dimensional analysis to make this all work out. So in this problem, let's start here at the bottom, mole to mole conversions, right here. The problem reads, when excess aluminum reacts with 2.5 moles of chlorine gas, how many moles of aluminum chloride are formed? So there's your question. How many moles? And our starting point is 2.5 moles of chlorine gas. So 2.5 moles. So as you can see from this, we're in moles going to moles. That only requires a ratio. You're in moles, there's no prepping. You're stopping in moles, there's no polishing. So we really have just one step here. 2.50 moles of chlorine. And then I'll use the railroad tracks. Most other teachers use railroad tracks. And then we are converting out of moles of chlorine. So on the bottom, we've done dimensional analysis all year. And we're going to aluminum chloride. And now the numbers will come from our coefficients. Aluminum chloride is 2 and chlorine is a 3. So that is a 2:3 ratio. And now all we have to do is calculate. So using our calculator, 2.5, any number that's on top in this is a multiplication. 2.5 times 2, which is 5. And then we'll divide that by 3. And then we'll round it to 3 sig figs, 1.67 moles of aluminum chloride. So that's a stoichiometry problem and nothing else. Mole to mole. All right, let's go to another type. So if you flip the page, you'll see the next section called mole to mass and mass to mole. So let's take a look at this first example. Balance the following reaction. All right, let's do that. So I've got 2 chlorine, so let's put a 2 here, which means I need a 2 in front of sodium. All right. Sodium chloride is decomposed into the elements sodium and chlorine by electrical energy. How many grams of chlorine gas? All right, so look at there, grams of chlorine gas can be obtained from 2.5 moles. All right, so this time we're starting in moles. That's great. No prepping needed. We're ready to go. Ready to jump right into the ratio. So we're going to grams, but I can't just do that. I have to go to moles first. Get to moles, use the ratio in moles. So moles of chlorine on top is what I'm looking for. And I want moles, I should have put NaCl here. Moles of NaCl is my starting point, and they'll cancel. So that ratio from our balanced equation is 1 to 2. All right, now I'm going to stop at this point and simplify. So we have 1.25 excuse me, moles of chlorine. And because I want you to see here, this is the end of step 1, end of Stoich, which is step 1. And now it wants us to go to grams. So let's add another conversion. So I keep forgetting we're going to do the railroad tracks. So moles of chlorine on bottom, as always, got to cancel that unit right there. And we want grams. So here's where we apply molar mass. So it was so important to learn that early in the year. So we go to the periodic table, find chlorine. This is Cl2. 1 mole of chlorine is going to be 35.5, either times 2, or you can say 35.5 plus 35.5. Either way, the molar mass of chlorine is 71. So we've got one more multiplication to do. 1.25 times 71. And I'm going to round that one to 3 sig figs also and get, I'm going to write it over here, run out of space, 88.8 grams of chlorine. All right, I'm just scanning through and seeing if I have another one. Yeah, let's flip a page again, and let's look at number 4. Excuse me, Corona's the worst. All right, so balance the following equation. Here we have propane burning in oxygen. So let's balance this. Remember how we did this? 3 carbons means 3 CO2s, 8 hydrogens, so you have half that many water. 6 plus 4 is 10, so we have 5 oxygens, always 3 steps. Now, looking at this problem, it says how many moles of carbon dioxide? So, question mark moles. If I burn 23.8 grams of propane. Okay, so this time we're starting in moles. And that means I have to prep. We cannot go to the ratio first until I get into moles. You've got to be in moles first. All right, so let's do dimensional analysis. We'll put grams on bottom, and we're going to convert to moles of propane. And our tool to do that will be the molar mass. So again, go into the periodic table, follow along with it, grab it, hit pause, grab it if you need to. But carbon has a mass of 12. There's 3 of them. So 36 plus 8 times 1. Hydrogen is 1 each. So that is a molar mass of 44 for propane. If you have any questions about this molar mass part, make sure you contact the teacher and get us to explain it to you, okay? So we're marking out the grams. Now we are in moles, and now we're ready to do some Stoich. So I'm going to just add another step here without getting the answer. Moles of C3H8, and I want to convert to CO2. So all stoichiometry can do is give me moles. I need a ratio of CO2 to propane. So 3 to 1. 3 to 1 ratio. All right, so let's get the calculator out. Let's do some math. By the way, the moles here canceled. All right, so 23.8, and let's divide that by 44. Okay, I get like 0.54, and then let's multiply it times 3. 3's on top. So to 3 sig figs, this gives me 1.62 moles of CO2. And that's all it asked for. There's no polish in this problem. Again, it asked for moles. All right, so that's a couple of examples of two-step problems. And the last one would be if we had to do prep and polish in the same problem. It just means we have 3 steps, and that's as big as it can be. So let's go and do number 1 here in this last section, and then I'm going to let you practice. We're going to have magnesium hydroxide, and the question says, what mass of HCl, so there's my question, mass, so grams, is neutralized by a dose of milk of magnesia containing 3.26 grams. So as you can see, we're in grams going 2 grams. So I'm going to have to prep to get to moles. I'm going to have to stoich to get into HCl, and then I'm going to have to polish to get grams of HCl. So 3 steps. Let's begin with 3.26 grams of milk of magnesia, and let's prep it. So we'll put grams on bottom, and we'll put moles on top. So 1 mole. All right, we got to add this up. So back to the periodic table, I got 1 magnesium atom, 24.3, plus 2 oxygens, so 16 plus 16, and then 2 hydrogens, so 1 plus 1. 58.3 is the molar mass. So that's my prep. Now I'm in moles. So let's roll into the Stoich step, and we're going to cancel moles of magnesium hydroxide and convert it into moles of HCl. Now here's our ratio from the coefficient. So there's 2 of these for every 1 of those. And the units cancel. All right, so that's our Stoich. And then let's polish it off. So let's get rid of moles of HCl and convert it into grams. 1 mole of HCl using the molar mass, 1 H and 1 Cl, 36.5. Cancel those units, and then let's do our math. So let's start with 3.26. Let's divide it by 58.3. Let's multiply that times 2. And then let's multiply that answer times 36.5. And rounding to 3 sig figs, 4.08 grams of HCl. And that's it. That was about as hard as it gets with basic Stoich conversions. We got to prep it sometimes. We always have to use the ratio. And then sometimes we have to polish it for up to 3 steps. All right, so what you're going to do now is there's a little mixed practice where I don't tell you which of those problems we're going to have. Some will be 1, some will be 2, some will be 3 steps. It's up to you to read the word problem and figure out how many steps you have to take. But complete that mixed practice, and we'll turn that in for a homework check. Let your teacher know if you have any questions.